What are we talking about today?
Metamaterials. Metamaterials are man-made materials with molecular structures that cause unusual refractive properties. Here we have an example of one of those properties. Here is a metamaterial and a non-metamaterial. In the non-metamaterial, this wavelength refracts at an angle that we would expect. In the metamaterial, the wavelength actually refracts in a negative manner.
A future application of metamaterials is seismic cloaking. Seismic metamaterials are engineered to counteract the negative effects of the Earth's surface level seismic waves, otherwise known as earthquakes. Take a modern day skyscraper, for example. Most of them have a basement filled with structural supports. When a seismic wave comes through, it damages these supports, causing the structure to collapse due to damage to these supports. With a metamaterial cloaking, as seen in red, the waves are actually bent around the structural supports. From a top-down view, it's much easier to see. The waves just seem to pass through it, even though they're actually being bent around it. The way it looks on a single support is as the wave passes through, so to speak, it is actually bent around and continues on its path.
Some of the benefits of the seismic cloaking technology was that we would save millions of dollars that would otherwise be used to rebuild damaged structures, and we would also save countless lives.
More possible applications of metamaterials could be using their properties to absorb sound waves, which would give us both silent engines and noise-canceling headphones. And metamaterials could also be used to coat antennae, which would reduce the radio interference between multiple antennae. And metamaterials can also bend light around an object, which would eventually give us the possibility of creating an invisibility cloak.